Happy Friday. All right, I hope everyone's going to have a wonderful weekend. You have your last class. It's beautiful outside, so I hope you're going to do something nice this weekend outside, get some fresh air and get away from the screen for a little bit. So let's go ahead and dive into reflections. That's our next type of transformation that we're going to talk about. And then on Monday, we'll kind of summarize everything, make sure we're good to go, and then move on to rotations for a little bit. So along with translation, so make sure you have your reflections section out in your guided notes. If not, if you go back one slide, you can print this set of notes so that you have it, or you can just take notes on a piece of paper. Either way works, as long as you have something to reference back to anytime you need to take a quiz or do a project or anything of that sort. It's helpful to have these resources available to you. So along with translations, reflections are also, and then we're going to kind of change this a little bit. We're going to get rid of that and a rigid motion. So remember, we talked about a rigid motion means that we're performing some type of transformation, but that the object is staying the exact same size. Another word for this is an isometry. Depending on the textbook, they're either going to use rigid motion or isometry. We're going to use rigid motion because that's what the MCAS uses. So I want to make sure we're using the same type of vocabulary that you'll see on the MCAS in May. And reflections is simply are going to flip an image over a line. So notice here we have triangle ABC, and that's our pre-image. And what's going to happen with our reflection is that this point C is going to be the same distance away from this line. Let's call this line L. So we're going to go the same distance away, perpendicular to this line, and this is going to be C prime. It's going to be the same. It's going to be, we have a distance. Let's see if I can do something. We're going to do this same exact distance this way. And we have B prime. And then for A and A prime, we have the distance from A to our line, which is going to be the exact same distance from our line to A prime. And obviously we would want to be more exact if we were doing this by hand. So that gives us all of our distances. And so again, these two distances are going to be congruent. Unlike translations, notice the distance from our the distance that like the point B traveled to get to B prime is not the same that the distance the point C traveled to get to C prime. This distance is significantly longer, right? What's the same, or the distance that's the same, is the distance from a point to the line of reflection, and then from that line of reflection to its image. So we now have triangle A prime, B prime, C prime. And notice a couple of things about reflections. Notice that if we were to read these points going in clockwise order, we would have point A, B, C. But when we read them for our image, this is now our image, we have C prime, B prime, A prime. So everything's been reversed. It's been flipped. But what we can say is that now triangle ABC is mapped to, that's what this arrow implies, triangle A prime, B prime, C prime. And the way we would know to do a reflection, notice, remember with translations, it was a capital T. With reflections, we use a capital R. And then here we have the line L. So we would write L. So this right here is our line of reflection. And then we would say triangle ABC equals triangle A prime, B prime, C prime. All right, so a reflection involves a flip of an image, usually over the X or Y axis. However, it can also be over any line. So I'm going to show you an example of like what Y equals X, Y equals negative X, X equal 2, Y equal 2. So some really common lines that we may reflect over. And the best way to graph the image of a reflection is to simply graph the pre-image and then measure the distance of the line. I'll show you how to do that in a minute. And then find the image the same distance on the other side of the line. So let me show you what some of these lines look like. And this is one of the big reasons we've been graphing these horizontal and vertical lines. So let's start first with just the line y equals 2. So I'm going to go to 2 on my y-axis, and y equals 2 is going to be a horizontal line through the point 2. So go ahead and label this line as y equals 2. Conversely, x equals 2, we go to the x-axis, and if I were to draw a horizontal line here, everywhere on that line, y would equal 0. That wouldn't be correct for x equals 2, because what I want is for every point on that line to have an x value in its ordered pair of 2. So that requires having a vertical line. So x equals 2 is a vertical line, that's this green one, through the point where x equals 2. So we're going to reflect over our x-axis quite a bit, our y-axis quite a bit, but then sometimes we're going to be asked to graph a line like y equals 2 and reflect over that line, or x equals 2. So we want to make sure we're graphing those appropriately. And all x equals are going to be vertical lines, and all y equals some constant without a slope, or with a slope of 0, are going to be horizontal lines. The other type of line that's really common in this instance or with reflections are y equals x and y equals negative x. So we've graphed both a few times in our algebra review. But if we have the line y equals x, I can rewrite that as y equals 1x plus 0. This line is actually called a direct variation. It goes through my origin at 0, 0, and then I go up one to the right one, up one to the right one, all the way through. So notice that every single point, like this is the ordered pair 1, 1, 2, 2, 3, 3, my x value and my y value are equal. So its equation almost tells you exactly, tells you exactly what's going on. That was bad. Let's go back. There we go. So we have this line right here, and that is y equals x. So sorry, its equation tells you what's going on. At every point, y equals x and x equals y. Conversely, we have this line y equals negative x, and it's really similar. The only difference now is that I have a -1 as my slope. So I'm still starting at my origin, 0, 0, but then I'm going up one to the left one. Or I could be going down one to the right one. So this line goes through my origin. But has a negative slope. So in this situation, y equals a negative x and x equals a negative y. So they're essentially like flip-flopping. So notice I have the point -1, 1, -2, 2, -3, +3. So my x and my y are opposite values. And then down here it's switching. So now I have a positive x and a negative y. But all the way throughout, my x and y are of opposite values. All right, let's take a look at an example. So we're going to graph and reflect the pre-image of triangle ABC over the x-axis. So I'm going to go ahead and start first by graphing triangle ABC. So we have 5, 0. We have 3, 1, 2, 3, -1. And we have 4, -3. So we have this triangle right here. And now when we reflect over an axis, all you're going to do, remember, it has to be the same distance away from that axis. So to create my pre-image, all I'm going to do is count how many spaces I'm away from this x-axis and then count the same number of ways in the opposite direction. So it takes me one space to get to my line of reflection of the x-axis. So I need to go one space past my x-axis. If I were to take this piece of paper and fold it over my x-axis now, these 2 points would match up perfectly. Point C is 3 spaces away, so I need to go 3 spaces away in my opposite direction. And then notice point A is right on my line of reflection. So it's just going to stay right there, because again, if I were to fold a piece of paper along my line of reflection, I would see that this point A wouldn't move at all. This point C would be copycatted 3 spaces away, the same direction. So we have triangle A prime, B prime, C prime right there. All right, next up we have again triangle ABC, just with different points this time. So go ahead and plot that while I'm plotting mine. So now we have triangle ABC. This time we're reflecting over the y-axis. So I'm going to do the same thing. I'm going to start with point A. I'm going 1, 2, 3, 4, 5 spaces away from my line of reflection, which is the y-axis. So I'm going to go 1, 2, 3, 4, 5 spaces away in the opposite direction. Again here, 1, 2, 3, 4, 1, 2, 3, 4. And then C prime is 1 space away, so it goes 1 space away. Notice that C prime was on the other side of our line of reflection. That's totally fine. We're just going to count the number of spaces it takes and then go in the opposite direction. Again, if you had this triangle and you folded it over, imagine this piece of paper being folded, or this coordinate plane being folded along my y-axis. That point C would now be on the opposite side. So they're just flip-flopping sides. So then we're going to connect our points. So we have C prime to A prime. And because this is a rigid motion, it should look the exact same size, and this does, so we're good. So honestly, the easiest way for reflections, because you know I'm not like a memorize type person at all. I'd rather you understand the process than memorize a bunch of rules. The easiest way for you to do these, if you have a horizontal or a vertical line of reflection, is just to count the spaces. Don't think about what the ordered pairs are as much, just count the spaces. But there are some abbreviations and there are some rules that if you are good at memorizing and you would prefer this path, you can absolutely do. So a reflection over the x-axis would look like a reflection over the x-axis of some figure. We're just going to say xy in this case. And that means that our xy, you'll notice when we reflected over the x-axis, our x-axis stayed, our x value stayed the exact same, and our y value became opposite. For example, if you started with the point 2, 3, actually let's do 2, -3, then when we do, when we perform a reflection over the x-axis, my 2 is going to stay 2, but that -3 is going to be the opposite, or we're going to negate the -3, which makes it a +3. So again, let me show you that over here in just kind of a makeshift. We had 2, -3. When we reflect over here, we're going 3 spaces, so we go 3 spaces. This would now be the point 2, 3. So notice my x value stays exactly the same, and my y value just becomes its opposite. A reflection over the y-axis of an ordered pair x comma y. In this case, I'm going to do the opposite of x, and my y value would stay constant. So now if we had 5, -4, I'm going to do the opposite of 5, which is -5, and keep -4 as it is. So again, just to kind of have a visual of that, 5, -4. If I'm reflecting over the y-axis, I need to go 5 spaces to the left to get to the y-axis. So I need to go an additional 5 spaces this way. So I would be at -5, -4. A reflection over y equals x. We would say r y equals x of xy. And because this, in this instance, our x and our y are equal to each other, when we reflect over this line, all you're doing is swapping them. So xy would become yx. And if we're reflecting over the line y equals negative x, now we're swapping and negating. So we're going to have a negative y, negative x. These two are worth memorizing. And really, you can just look at the equation, y equals x. So I'm switching. I need my x to equal y, and I need my y to equal x. For y equals negative x, I need my y to equal negative x, and I need my negative y to equal positive x, so that if I were to divide by negative on each side, I would have y equals negative x here. So you can kind of think it through too. But trying to draw that perpendicular line is a little bit more challenging when you're dealing with a line y equals x, and we're going to look at that in just a second. All right, so now we're graphing over the line y equals negative x. So let's start by graphing this quadrilateral. So go ahead and plot those points. And then after you have that line draw, go ahead and draw your line of reflection as well, which is y equals negative x. So again, that goes through your origin and then has a slope of -1. So this is the line y equals negative x. So you do have the option, if it works out that way, to just say, okay, well, I'm drawing the perpendicular here. This is going half of a space, so I need to go a half a space this way. So this would be B prime. But notice this is the ordered pair. B had the ordered pair -3, 2. So we should expect for B prime to be -2, +3, because I'm doing the opposite of each of these and switching the order. And let's check. -2, +3, it checks. I'm going to go over here and just follow the rule from the previous section. For all of them, I'm going to switch them and negate both of them. So this is going to now be -4, +2. C prime would be -3, -1, and D prime would be -5, -2. So A prime should be -4, +2. Notice it's about along the diagonal, a space away, along the diagonal, a space away, so that's A prime. C prime should be -3, -1, -3, -1. Let's check it. This one's a little bit more challenging. Oh, I went the wrong way. See, that's why it's nice to check. -3, -1. So it should be down here. All right. 1, 2, 1, 2. I'm good. All right. Next up, we have -5, -2, -5, -2. That's a D prime. Now I'm going to check. I'm going along this diagonal. We're good. So now I can go ahead and connect all of my points. And that's a reflection over, so if we were to fold this piece of paper along that pink line, and maybe like put like a really heavy ink on this A, B, C, D, it would make an imprint on the other side, where A prime, B prime, C prime, D prime would be. All right, now we're going to reflect over the line x equals -3. So let's draw, go ahead and first draw triangle ABC. Then we're going to draw on the line x equals -3. So I'm going to where x is -3 and then doing a vertical line. And then I'm just going to go ahead and count my spaces. So I am 2 spaces away. So I need to go 2 spaces away. This is going to be B prime. 1 space away, 1 space away, C prime. 3 spaces away, 3 spaces away, A prime. And I'm done. All right, the last one. Notice there's no, I think this is the last one. Yep. Notice that there's no coordinate plane this time. So that changes things, right? So I'm going to go ahead and I'm going to look at those rules on the previous page. And it says that when I'm reflecting over, so when I have a reflection over the line y equals x of some xy, that's going to just give me y comma x. So if I'm just finding these coordinates, f prime is just going to be flipped. So -2, 5. R prime is going to be 0, 10. E prime is going to be 12, -5. And D prime is going to be -3, 0. And I'm done. If this had been y equals -x, I also would have negated both of these on each of the ordered pairs. All right, so hopefully you've done this one on your own and you typed in the ordered pair you got for L prime into the pear deck so that I can see how we're doing on our first try. And now you're going to watch through the solution to see if you got the right answer. So we're going to go ahead and reflect over the line y equals x. So I'm going to draw in that line y equals x right here. And then I'm going to go ahead and reflect. Notice that S is right on the line, so that's going to stay. S and S prime are going to be the same. There's not going to be any difference there. Then we're going to have X. X prime will be right down here. L is a little bit far away. I'm gonna instead use the fact that 1, 2, 3, 4, 5. So this is at -5, 3. I'm reflecting on the line YX, so I need to go to 3, -5. So this is L prime. So that should be your ordered pair that you're putting in, 3, -5. And then K is at 1, 2, 3, 1, 2, 3, 4, 5. So K is at 3, 5. So it's going to be at 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. All right, let me get my, so this stayed the same. This guy goes down there. Notice that's a short distance. This is a much further distance. And then notice something here. I made a little mistake, right? And I knew something was off. So I looked here and I'm like, ooh, that's a really long line and that's a really short line. So I'm going to look back at my ordered pair and notice that I made this a +3. This should be a -3 because I went to the left. We all make mistakes in math. It happens all the time. So it's really important that when you make a mistake, or rather while you're going through a process, if something seems wrong, go back and look back at your work and see what that was. So this, I realized that, oops, that was a -3. So when I flip them, I should have 5, -3. So 1, 2, 3, 4, 5, 1, 2, 3. That makes so much more sense, right? Because see how this is kind of like 2 diagonal spaces away? This needs to be 2 diagonal spaces away. So now I feel much better about my solution. And we're done. All right, now we're reflecting over the x-axis. So my D and D prime are going to stay exactly the same. Z is 4 spaces away, so Z prime needs to be 4 spaces away. Y is 3 spaces away, so we need to be 3 spaces away here. So this is what our triangle should look like, although I hope your lines are straighter than mine. We're looking for point Z after the reflection. So you should have had -3, -4 as your solution for Z prime. All right, lastly, So this one's a little different. You're going to complete these problems, which you may want to do off to the side on a piece of paper. I'm hoping that's what you did, or you were able to just kind of reason them out. And then you're going to just come back, and I want you to circle back to these problems and just circle any, try the best you can, or just mark up any of these questions that you got wrong so that I have an idea of where you're at with these types of problems. So for question number 3, we were originally given, so we're reflecting over the line x equals 4, and our original points were 3, -5, 3, -4, and p was 5, -4. So I'm just going to do a rough sketch over here. I have the line x equals 4, so this is my line of reflection right here. And then I have my points are 3, -5, that's F. This is 3, -5. So if I reflected this point over that line, notice I'm 5 spaces away from my x-axis, and then another 4 spaces. So all together, I'm 9 spaces away. So that means I need to go 9 spaces in this direction. So notice my x value hasn't changed at all. So I'm going to start there. F prime, my 3 is staying 3. But now I'm going 9 spaces, and then I'm going another 9 spaces. So I'm going 18 spaces altogether. So I'm going to add 18 to -5, and that's going to give me a positive 13. So we should have gotten 3, 13. Same here, I'm starting at 3, -4 this time. So I'm just right above here for C, which means in this case, I'm 4 spaces to my x-axis. This is the line x equals 4. So then I'm another 4. So I'm 8 spaces away from my line of reflection, which means I need to go another 8 spaces to get to my new point. So I need to add 16 to this. So I'm going to add 16 to -4. C prime is going to be at 3, 12. And that makes sense because notice these are 1 space away and these are 1 space away. Lastly, we have P prime. 5 is going to stay the same. I'm at -4, just like I was in my last problem. So I know I need to add 16. So this is going to be at 12. And notice these two values were the same. So I knew that these two values needed to be the same. For question number 4, now we're reflecting over the line y equals -x. For this one, I'm not going to graph it at all. I'm just going to use those rules that I have on the previous page for reflecting over the line y equals -x. So I know I'm going to flip them and negate them. So x prime would be 3, 4. M prime is going to be 2, 3. And I prime is going to be 5, 1. For question number 5, we're reflecting over the y-axis. So I'm starting with n, which is -3, 1. G is 0, 4, and B is -1, 1. So I'm going to go ahead, if I'm reflecting over the y-axis, I can use those rules on the previous page, but I know that my y stays the same, that stays 1, and then this changes to its opposite. So it's going to be 3, 1. G prime will stay 0 and stay 4 because that point's on my y-axis. And then B prime is going to be, we're going to do the opposite here, so that'll be 1, and this will stay 1. For our last question, question 6, we're reflecting over the x-axis. And our original points are W, -4, 4, U, 1, 5, and K, 0, 0. So in this case, because I'm reflecting over my x-axis, my x value stays the same, my y value changes to its opposite. So x stays the same, y is its opposite. And both of these, there's no polarity with the number 0. So it stays 0, 0. All right, I have some problems. Actually, we'll stop